Hello, students. Welcome to the world of chemistry. I am Mrs. V.R. Thongepati, chemistry teacher in Sri Shivaji Vidya Mandir and Junior College, Aundh. Today, we are going to start with lesson number 7 of your syllabus, that is modern periodic table. So, let us have a look at this table. This is your modern periodic table. You have been introduced with this table in your school days only because this is the base of chemistry. It tells us about all the elements which exist in nature. Those elements were arranged in a typical manner. In short, we can say that this is the classification of elements. And for doing this classification, some criteria are applied. We are going to learn in detail about it in this year also. So, let us begin with the lesson Modern Periodic Table. In the early 19th century, about 30 elements were known, and those were classified into three types based on the criteria that their physical properties are considered. And by considering the physical properties, they are classified into three types as metals, non-metals, and metalloids. We know about metals, non-metals, but day by day, new elements were discovered and it became very difficult to remember them because every element has different properties. So, it was needed to classify these elements properly so that everybody knows and remember them with their properties. And considering this aspect, many scientists came up with their ideas to classify these elements. Out of these scientists, some noteworthy attempts were made by two scientists, namely Dauvergne and Newlands. Dauvergne prepared triads. That means he prepared a group of three elements which are placed in the increasing order of their atomic mass and with similar physical properties. And he prepared the group of three, hence, those are called as triads. They gave a basic idea about this, that physical properties should be considered. One more scientist also tried, as I told you, is a Newland. He placed elements in increasing order of atomic masses, and it was noted by him that every eighth element had similar properties to that of first element. And hence he prepared a group of 8 elements, and those are called Newland's octaves. These attempts were good enough, but not satisfactory, or we can say they are not sufficient, because as the number of discovered elements increased, those theories were insufficient. Finally, in 1869, a Russian chemist, namely Dmitry Mendeleev, he came up with his idea to classify these elements based on atomic mass and properties of elements. He is the one who prepared periodic table of 63 elements known at that time. He arranged these elements in horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that the elements with similar properties occupied the same vertical column. He called it as group. His table was based on his law, and the law is known as Mendeleev's periodic law. And this law stated as the physical and chemical properties of elements are periodic function of their atomic masses. Do you understand by this? What does it mean? Now, some different words are there used. The one is a periodic function. The physical and chemical properties you understand by that. The properties of the elements, they are the periodic function of their atomic masses. It means after certain period, property repeats. Here we can say after certain number of elements, a new element with similar property reoccurs. Understood? What is meant by periodic function? After some period, a property repeats, or after some elements, a new element with similar property reoccurs. And hence, the name given to this table is periodic table and the law is periodic law. Mendeleev arranged the elements known at the time in an increasing order of their atomic masses from left to right. He kept one in front of another like this in the increasing order of their atomic masses, and he prepared a horizontal row of these elements, and to that row he called periods. Then he folded that list, folded in such a way that the elements with similar property will be placed in same vertical column, one below another. Understood? He prepared a horizontal row by keeping the elements in the increasing order of their atomic masses, and then he folded that list such that element with similar property will come one below another in a vertical column. He called it a group. In short, in his periodic table, elements belonging to the same group showed similar properties. And properties of elements in a period or horizontal row showed gradual variation from left to right. Understood? So, the elements in a row show gradual change, while element in a vertical column, that is group, shows similar properties. Mendeleev left some gaps corresponding to certain atomic numbers in the periodic table so as to maintain the periodicity of the properties. Because he has to keep the elements with similar properties in one group. So some gaps he left, and he told that at his time, after the discovery of new element with the similar property you may find, and it has this place. He just given his prediction, and after this, the newly discovered elements fitted well into the gaps with their properties as predicted by Mendeleev's periodic law. So his predictions were perfect. Now, at the time of Mendeleev, inert gases were not discovered. And he also has no idea about inert gases because these gases are monoatomic. They don't react with any other element. Hence, their compounds were not known. And hence, their discovery was very late. They were not occurred or they were not discovered at the time of Mendeleev. Hence, he hasn't predicted anything about inert gas. But these inert gases are also accommodated in his periodic table, and for that, a separate additional group was prepared. We call it group number 18, and that was kept to the extreme right of the periodic table where all the properties end, and it fitted well there. So, the Mendeleev's periodic table now it is complete. But still, some drawbacks were there, and those were discovered after the Henry Moseley's work, which he made in 1913 on the X-ray spectroscopic study he made of large number of elements. And that study showed that X-ray emitted by an element is related to atomic number and not the atomic mass. And after the discovery of atomic structure also, the atomic number Z was considered as a more fundamental property of the atom than that of atomic mass. So these two reasons are there. One more reason is that after the discovery of isotopes, it was found that an element with different mass number occurs. Then what to do? For example, suppose we take example of oxygen. Oxygen has three isotopes. Oxygen with mass number 16, 17 and 18. Hydrogen also has three isotopes. Hydrogen with mass number 1, 2 as well as 3. But helium also exists with mass number 2. Lithium with mass number 3 is there. So which should be kept in the bracket, in that square of with mass number 3, whether it should be lithium or tritium, which is the isotope hydrogen. So the problem arises. And then it was found after the study of atomic structure that Z, that is the atomic number, which is also the number of protons as well as electrons. That was more fundamental property. Why? Because it doesn't changes. It is the identity of that element. Atomic number is fixed. So when we say 17, it is chlorine. When we say 9, it is fluorine. Like that. That is the identity of that element. Hence, instead of atomic mass, if atomic number is considered, then Mendeleev's periodic law should be modified. And hence, it was modified, and a new periodic law called modern periodic law came into existence. And this modern periodic law stated as: the physical and chemical properties of elements are periodic function of their atomic number. Only changes one word, that is number instead of mass. So atomic number is the more fundamental term. All other words, all other meaning remains same. That means after some element the property reoccurs, or it is a periodic function of atomic number. That means the element should be arranged in their increasing atomic number in horizontal rows, and in vertical columns after certain number of elements, element with the same property occurs, and that should be kept in single group, one below another. Understood? And hence a new structure has been introduced. Some changes are made, basic changes, and that is called as long form of periodic table, or it is called as modern periodic table. And this is the modified form. It is the revised version of Mendeleev's periodic table, and it is the most convenient and wisely used form of the periodic table. It is widely used all over the world, and is the accepted form all over the world. And hence, the modern periodic table, what are the features of that? The features are like this. The modern periodic table has horizontal rows, and the vertical columns intersect them, and the squares or the boxes formed by the intersection of rows and columns where the elements are placed. The horizontal rows are called as periods, and the vertical columns are called as groups. There are in all 7 periods. Those are numbered as 1 to 7, one below another. And there are 18 columns side by side to each other, numbered from 1 to 18 in this modern periodic table. The boxes formed at the intersection of the periods and groups are places for the individual elements. Below the main table, there are 2 separate series containing 14 elements each, and that is a separate block. This periodic table has in all 118 elements accommodated in it. The overall shape of the modern periodic table, we will take another look at it after some time. The overall shape of the modern periodic table, if we consider, there are 4 different blocks. So another type of classification is also possible with this periodic table. That means this periodic table is divided into 4 blocks. 2 groups at the extreme left are the S block elements. 6 groups on the right side, they are P block elements. 10 groups in the center of S and P block, they belong to D block. And the 2 series containing 14 elements each, which are placed at the bottom of the periodic table, they are A block elements. So this is all about periodic table, or basic knowledge about periodic table. So let us have another look at the periodic table, and just we will apply all the criteria to this periodic table and try to understand it. Now, as for modern periodic law, all the elements, if you see, they are arranged in the increasing order from left to right. That is hydrogen with atomic number 1 is here, helium with 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So if you see the increasing order from left to right. As well as there are vertical columns, and if you see all the halogens are placed in the 17th group here. This is 17th group with fluorine, chlorine, bromine, iodine. We call them halogens. These are the inert gases, 18th group. In the first column, there are alkali metals. So, the elements with similar properties are placed in one group, while the elements with increasing atomic number placed horizontally. There are 7 periods. You can see 1, 2, 3, 4, 5, 6, 7. There are 18 columns, that means 18 groups. And 2 separate series containing 14 elements each are placed below the main periodic table. One element extra, lanthanum and actinium is there. That is actually the 15th element that should be kept here. So after lanthanum and after actinium, like this. So this is the periodic table with 18 groups and 7 periods. Now, about the 4 blocks. The 2 groups to the extreme left contain only active metals. These are S block elements, that is group number 1 and 2. So this is S block, first 2 groups to the extreme left. To the right, 6 groups from 13, 14, 15, 16, 17, 18. So 13 to 18. These 6 groups are P block elements. These 2 are S block elements, while these 6 groups are P block elements. In between S block and P block, these 10 groups, those belong to D block. And this is a block containing total 28 elements. Actually, the location of a block is like this. The upper series that is here in the third group and sixth period. Here you can see 57 to 71 written like this. That means this first series, complete first series, upper series should be placed in this place, that is in the third group and sixth period. But it can't be accommodated there because all the elements have almost similar property to that of third group. It can't be accommodated there, hence it is kept separately below the bottom. Like that, the lower series from 89 to 103, after actinum, those elements should be there in the 7th period and third group. Here. So, this again the same reason, these 14 elements cannot be accommodated in the third group and 7th period, hence they are kept separately and they are called F block elements. This total periodic table, this is the introductory part. We are going to learn about it in detail in the coming sessions. But there should be some practice. And for that purpose, I have given first assignment based on this periodic table. And that is, draw long form of periodic table in your notebook. So, in your textbook on page number 94, the figure of periodic table has been given. You just have to draw 18 columns and 7 periods, and you don't have to show all the elements in it. Just draw the outline, showing the numbers from 1 to 18, showing the position of S block, P block, D block and F block. Don't write all the elements in it. Only write down the numbers, how they are arranged and blocks in that outline of the periodic table. Understood? So, this is about today's session. Thank you.